Hello, my name is Patrick Altmaier. I'm a PhD student in Trustworthy AI at Delft University of Technology. I've previously worked as an economist for the Bank of England and studied both economics and data science in the UK and Barcelona in Spain. My co-authors are Marco Agusti and Ignacio Vidal Cuadras Costa. They both work at the European Central Bank at the moment. And together during our masters earlier this year, we wrote up this paper or started this research on adding deep learning to vector autoregression. A quick disclaimer before I dive into the actual research. The views expressed here and also any errors are our own and not those of Delft University of Technology or the European Central Bank. And with that out of the way, let me dive straight into the poster, which you will also be able to see during the workshop. So yeah, as the very revealing title says, we asked ourselves if we can leverage the power of deep learning in vector autoregressive models. They're a standard tool used by central bankers and other practitioners for forecasting, but also for inference purposes to understand, for example, the interactions of variables in the monetary transmission mechanism. Our contributions can be summarized as follows. We provide a very simple extension of the conventional benchmark, which was important to us to keep things kind of close to the trusted methodology that people already use. By introducing the small extension, we achieve significant improvement in model and forecasting performance. And we also provide open source code, an R package, which is still under development, but the first kind of working version is on GitHub. So let's just quickly discuss the methodology. In the VAR, you have a system of linear equations, and they're modeled typically linearly through ordinarily squares. What we do is we relax that assumption of linearity and instead model each equation as a recurrent neural network. So to just illustrate this here, we have as inputs lags of the variable itself. So for example, output and all other variables in the system. Then we have a couple of hidden layers. The design is totally up to the researcher's practitioner's discretion. And then the final output unit, which is the variable in time t. And we have one such neural network for each of the variables in the system. We take this model to the data. Particularly, we use the FredMD data set on monthly US data on output, unemployment, inflation, and interest rates. And we can see that, here in red, the cumulative loss of our proposed methodology is much, much lower than that of the conventional VAR here in purple, and also another popular approach to VAR that actually addresses nonlinearity. So we outperform that one as well. This is just a quick table that shows how the model performs for the test sample. I'm happy to go through into more detail here during the actual workshop. Similarly, let me skip the part on hyperparameter tuning in this short presentation and just quickly finish off with a note on what we've done since we presented the master's thesis in June this year. We have addressed, adding more benchmark models, such as in this case the threshold VAR, but we're open to suggestions as to what other models we should look at. Uncertainty quantification, in terms of coding that up, we've made progress, but it's still not at a place where we say that should be presented in this workshop. But there are certainly ways forward here. Initially, we've looked at Monte Carlo dropout, but there's also a very interesting paper actually being presented at NeurIPS this year, which shows that Laplace approximation seems to be promising for deep learning. So we'll look into that as well. Open questions are concerning structural identification. So one paper from Vestiok from Harvard uses Koleski on the residual covariance matrix. It seems a straightforward way to do this. Perhaps we just go forward with that approach as well. In general, though, there's lots of open questions still when it comes to kind of the traditional conventional tools that people use for inference purposes, such as input-response functions, variance decompositions, policy counterfactuals. And we hope to be able to address this in the future, but things are a lot more complex in this nonlinear world. And yeah, with that, let me wrap up. I'm slightly over time. Just a quick note on these QR codes. This one will take you to the package repository. This one will take you to my website. The package repository also has a link to the paper repository. So with all that said, thank you very much for this opportunity, and I'm looking forward to meeting you all in December.